Torque is the force applied to an object that causes the object to rotate. To do a complete 360 turn, there has to be a force applied to the back leg by pushing off the floor and a large distance between the back leg and front leg. The front leg becomes the axis of rotation. The axis of rotation needs to be aligned with the dancer's center of mass, so she won't lose balance. The distance, meaning the radius, between the back leg has to be perpendicular to the front leg, which becomes the axis of rotation. In order to produce torque, the larger the distance, the less force is required to produce torque. Dancer will not have to work as hard to make herself spin.
Pirouettes relate to Newton's first law, the law of inertia, which states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. In short, the factors that affect the continuation of the spin are mass and radius. The equation for inertia is mass times radius squared. This measurement of angular inertia determines how easy or difficult it is for the body to rotate around its axis. Or in the case of a pirouette, a greater mass creates a greater rotational inertia, meaning that it is harder to start and harder to continue spinning. Because a pirouette and rotational inertia are proportionate to the mass of the object, in order for her to rotate faster, she needs to decrease her mass, therefore decreasing this rotational inertia. The radius of the spin has an even greater effect. Performing the turn tightly towards the center of mass reduces the body's angular inertia, making it easier to spin. Another influence in her turn is friction. When the individual pushed off on the floor during takeoff and throughout the spin, the friction between the leg and the floor pushes the other way. This helps the individual maintain balance while also continuing their rotation.
To maintain angular momentum and further perform the spin easily, form drag must be minimized. This pressure drag force has an effect on the relative velocity of the body spinning through the air. We can minimize this force by adjusting the performer's technique and decreasing the cross-sectional area going through the air. For instance, notice the positioning of her right leg. Hip flexion is at a relative 90 degrees, and knee extension is at 135 degrees. We want her to maintain this angle in order to reduce the pressure at which the air is inducing on the body. Furthermore, the angle at which her arms are held is also important in the continuation of the spin. To decrease the drag force, we want the subject to hold her arms at a 90-degree flex position. The separation of air at this position would decrease, angular velocity is increased, and she will be able to continue the turn. Her arms being held at a low position may have led her to a fallout.
An object's center of mass is the point at the center of its weight distribution, where the force of gravity can be considered to act on the body as a whole. In the turn, the center of gravity is constant. It is located in the abdominals. In order to continue the turn, the center of gravity must remain vertical to the turning axis. Things that affect center of gravity: position/stacking of the body. Arms. To begin, the arms start outstretched and draw into a circular form anteriorly. Left leg, working leg. Position of knee is best when flexed at a 90-degree angle anteriorly to the hip. Right leg, standing leg. Right knee needs to be straight, no angle, stacked on top of the ball of the foot.
A person can increase their stability with a greater base of support. Base of support consists of the point of contact with the ground and all of the space between those points. When doing the pirouette, she began with a greater base of support, which put her at a state of balance. As she pushed off the ground, her base of support got narrowed down, putting most of her weight on one leg. Standing on one leg means that she has very little stability and can easily fall over. According to the principles of stability, keeping the projection of one's center of mass with the confines of the base of support would enhance balance. However, if the line falls outside of the base limit, then the object or person will lose its balance. In the video, we see the center of mass falling outside of the base limit as she rotated. Some actions were taken when she landed to regain balance. She took a step forward, extending her base of support to capture her center of mass.